Discrete probability distributions. Poisson. Poisson distribution. In the previous video, we learned about binomial distribution. In this video, we shall look at the other type of discrete variable Poisson distribution. If you recollect, in the binomial, the probability distribution of the number of times an outcome occurred in a fixed number of trials was considered. Thus, the random variable x had an upper limit. However, an upper limit on the number of opportunities for an outcome to occur cannot be logically fixed. For example, the number of black spots on a piece of cloth, the number of potential visitors to a departmental store. Poisson distribution can be used to analyze such situations. However, there are some requisites to use Poisson distribution. Firstly, the numerous opportunities for the occurrence of the outcome even when an upper limit exists, is a very large value, with a very low probability of occurrence of the outcome during an opportunity. If x denotes the random variable indicating the number of occurrences, which follows a Poisson distribution, the probabilities of x taking a given value, 0, 1, 2 and so on, depends on its expected value lambda. Lambda is the parameter of the distribution. For a given value of lambda, the probabilities can be obtained from tables or software. When x follows a Poisson distribution with parameter lambda, the following scenarios are true. Expected value of x equals lambda variance of x equals lambda standard deviation of x equals square root lambda. Let's understand this with an example. The number of spares required for any component in a machine during the equipment's life follows a Poisson distribution with lambda equals 2. A firm that uses this machine must decide how many spares of this component are needed so that the probability of a stockout is at most 0.06. How do you determine this number? Solution. Let the random variable x denote the number of spares required. X follows a Poisson distribution with parameter lambda equals 2. The table shows the stockout probabilities for different values of stocks. Note that stockout probability for a given value equals 1 minus cumulative value. Observe from the table that when 3 spares are stocked, the probability of a stockout is 0.1429. When fewer units are stocked, the stockout probabilities are higher. The stockout probability cannot exceed 0.06. Hence 3 or fewer are inadequate. When 4 units are stocked, the stockout probability is 0.0527, which is lower than 0.06. Since the stockout probability should not exceed 0.06, the firm should stock 4 units.